Hello everybody, this is Lorenzo Perella for Physics 116 Clark Wellman. Today we'll be going over lab 7, images and formed by two lenses. For this one, we need to use the thin lens equation and sign conventions to utilize the graphic ray tracing of how the light rays will work with two lenses separated by a certain distance. Now our distances are, our first focal length is 4 centimeters, and that our S1 is 11 centimeters to the left of the first lens, and our height is 3 centimeters. Our separation of the two lenses is 15 centimeters, with the second lens on the right and the first on the left. And our second focal length is 6.8 centimeters. Now these are our calculations here. So in order to figure out the first focal length, we have 1 divided by 11 centimeters, which was our given S1. And then find our S prime value, which is the image distance. We take 1 over 11 plus 1 over S, which equals 1 over 4, which was the first focal length. So to do so, we take 1 S prime is equal to 1 over 4 centimeters minus 1 over 11 centimeters, which is 0.15909 centimeters. Then we find the inverse of this value to give us 6.2857 centimeters, which is the distance that is between this point to out here. And secondly, we need to find the second focal distance, which is the first S minus the smaller s. That is 15 centimeters, which separates the two sides of the lens, minus 6.285 centimeters, and that gives us 8.714 centimeters for the object distance for the second lens. And then to find the other portion, take 1 over s plus 1 over 8 over 7.4 equals 1 over 6.8 centimeters, which is the value that we got. It's the value that was given for the second focal length. From there, we find that 1 over s is 0.0323. Then the inverse of this value is 30.95 centimeters, which is then to the right of the second lens. To validate this, we use a site called GeoGebra in order to validate our thing. Now, since we can't get it there, we have to increase everything by a factor of 100. Factor of 100. So 15 centimeters, because then 15 meters, which allows us to separate this by 15 meters. Now this isn't going to be perfect because we have to adjust and everything. So we make this 3 meters here, and the first focal length here to be 4 centimeters, which is then 4 over here. So that means this is about 6, a little over 6. And the other portion, by that note, should be 8.771 centimeters, which is right about here. Now, I will admit the second focal length is a bit off. You can fix it ever so slightly. It just takes a little bit of meddling around, and I understand the calculations for SI2 are a bit off, but bear in mind that this is not the best use of it, and that if we could do this in a lab, we would have a much better output for this kind of system. And this is what we would have via the GeoGebra, and then on our own, this is what we have. Now, it's not perfect, but it's the best we can do for this time being. Thank you. This is Lorenzo Perella for Physics 116 Clark Wellman. If you have any suggestions on what I could have done to improve it or anything like that, please leave a comment below. Have a wonderful day.